Hello. In this video we're going to continue to explore the quadratic relationship. We refer to this as quadratic function, but remember, a quadratic function is the same thing as a quadratic relationship. A function is just a special type of relationship which you may or may not have defined yet. So to start with, we're going to look at the most basic way to actually graph any type of relationship, and that is using a table of values. So here we have this table of values below, and what we want to imagine is we're imagining the following, that we're saying this: y is equal to x squared. And here we have y is equal to x squared plus 2. So what we're doing is we're taking an x value and we're putting it into the relationship to get the corresponding y. So negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. And again, what we want to check to make sure that this is right is this sense of symmetry. Notice that we have 0, 0, which is the vertex here. That's the vertex, the point 0, 0, and the graph should be symmetrical about the vertex. 1, 4, 9, 1, 4, 9. So now what we're going to do is we're going to go and do the same thing, but we're going to do it for x squared plus 2. Now, one way to do this, of course, is to take negative 3 and substitute it in for x squared and then work that out. So we have negative 3 squared, which is 9, plus 2. So 9 plus 2, which is 11. But again, what we want to stress here is the connection from our parent graph, or parent relationship, y equals x squared, and the new relationship, y equals x squared plus 2. Notice all we're doing is we're taking the y from y equals x squared relationship, the y value, which is 9, and then adding 2 to it. So 9 plus 2 is 11. 4 plus 2, 6. 1 plus 2, 3. 0 plus 2, 2. 1 plus 2, 3. 4 plus 2, 6. 9 plus 2, 11. Notice we get the same symmetrical idea here, 11, 6, 3, 2, 3, 6, 11, but we notice now the vertex is at 0, 2. So we've shifted the vertex up 2. Now let's take a look at the next one. So let's use that same idea. What we're going to do is we'll take the y from y equals x squared and subtract 5. So 9 minus 5 is 4. 4 minus 5 is minus 1. 1 minus 5 is minus 4. 0 minus 5 is minus 5. 1 minus 5 is minus 4. 4 minus 5 is minus 1. 9 minus 5 is 4. And we see now that same symmetrical behavior around the vertex, and the vertex here is going to be 0, minus 5. Remember, when I state the vertex, I always want to state both the x, y location. The vertex is a point in space. It's not just a single value. Now this one looks a little bit trickier here because it has a 1/2 in front of the x squared. So again, I could do a substitution process here. This is thought of as, we can think of this as y equals 1/2 x squared minus 1. So order of operations means that we're going to square it, then multiply the result by 1/2, and then subtract 1. So let's do this down here. So we're going to get, let's come down here. So we're going to get 1 over 2 times negative 3 squared minus 1 is going to give me 9 over 2 minus 1. And 9 over 2 minus 1 is going to be 7 over 2, which we can write as 3.5, and that might be helpful when we actually go and graph this later on. Now let's do the same thing here. So this is equal to 1/2 times negative 2 squared minus 1, which is going to give me 4 over 2 minus 1, which is going to give me 1. Now we'll come here. So we're going to get 1/2 times negative 1 squared minus 1, which is going to give me 1/2 minus 1, which is minus 1/2. Now we can do this one here, and so this one's going to be 1/2 times 0 squared, and notice 0 squared is 0, times 1/2 is 0, so this is just going to be minus 1. And again, we can continue along, and what you'll see here is you'll see this nice symmetrical idea. And you can confirm that yourself. So what we notice here is that when we add a constant after we've taken this, after we squared the value, it actually changes the y value by moving it up or down from my original parent graph. So notice here, from the original parent graph, y equals x squared, the y value at negative 3 is 9. If I add 2, it goes up by 2, so it becomes 11. If I subtract 5, it goes down by 5, so it becomes 4. This last example here is a little bit trickier because we have this vertical stretch here. And so in this case, we need to first apply the stretch before we shift it up or down. And now in our next video, we'll explore that in a little more detail. Hope that helped.